Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, just like we did for BJT, what we did is we first did the DC analysis of BJT and we studied certain DC applications of BJT such as current mirror circuit and voltage regulator circuits. Same way we will be proceeding in MOSFET. First we will be understanding about the DC analysis and DC application of MOSFET, and then on we will be proceeding to the MOSFET amplifier. So in this video what I'll do is I'll tell you about the biasing techniques that are used in MOSFET, and then I'll tell you how MOSFET circuit or MOSFET can be used in a current mirror circuit. Okay. So first of all, since you have already studied BJT, my first question to you guys is, what is meant by biasing? So what did I tell you earlier? Biasing. Biasing means applying DC voltages to establish operating point of device. Okay, or you can say operating region also. Now this operating point we used to call it as, this operating point is also called as what? Q point. Okay, Q point, which is also called as quiescent point, or we call it as no signal point. That is where there is no AC signal. So when there is no AC signal, only what we have is DC. Now there can be three operating regions as we have studied in MOSFET. What are the three regions? The first region is cutoff. Cutoff is when VGS is less than VT, or in case of PMOS, VSG is less than mod VTP. Then we have the second region is linear. VGS greater than VT and VDS less than VGS minus VT. Here VSG greater than mod VTP and VSD less than VSG minus mod VTP. Then the last one was saturation. In this case VDS would be greater than VGS minus VT, and it is understood that VGS is greater than VT. Here VSD would be greater than VSG minus mod VTP and VSG would be greater than mod VTP. So these are the conditions for different operating regions in case of NMOS and PMOS. So in MOSFET biasing, our focus will be on deriving the operating point or Q point. This Q point will be a combination of two values, ID and VDS. And for PMOS, we will replace this VDS by VSD. So we want this voltage similar to case of BJT. In BJT, what we were deriving? IC and VCE. Now collector is replaced by drain and emitter is replaced by source. So ID comma VDS. Everything is going analogously, just the device structure has changed, but the name and the functionality of terminals is still the same. So let us start with the first biasing technique. The first technique is called as fixed bias configuration. Now in the earlier problem solving video, as I showed you, how do we solve this? We first apply KVL like this. So what I will write? VG minus VGS minus IDRS equal to 0. So we can say VGS is VG minus IDRS. Now this drain current is unknown, right? We don't know the value of drain current, so you can't predict the value of VGS. Now just like in case of BJT, we will assume an operating region. In BJT we assume the operating region as active, but here we assume operating region as saturation. Here we start from saturation region. So in that case what I will say, ID is K VGS minus VT whole square. Now we can substitute the value of VGS, VG minus IDRS minus VT whole square. From here we can predict the value of ID by solving the quadratic equation. Now in order to justify whether operating region is correct or not, what I will do? I will find out this value VDS. How to find VDS? I will apply KVL like this. So I will write VDD minus IDRD minus VDS minus IDRS equal to 0. So from here I can calculate VDS, VDD minus ID RD plus RS. That is the value of VDS, and we know VGS is this. If your operating region assumption is correct, remember what we did in BJT, we assumed active region and then we validated our assumption. We need to check whether or not our assumption is correct. In order to check that, we have to find VGS and VDS. Now VGS is VG minus IDRS. If our assumption is correct, then this VGS must be greater than VT and this VDS must be greater than VGS minus VT. If such a thing happens, then our assumption is correct. If this condition, this VDS, if it is not true, then we have to assume linear region, and again we have to calculate VGS and VDS. So first I have assumed saturation, but then you will again assume linear and you will solve the problem again. So remember, in problems based on MOSFET, always start solving the problem based on assumption of saturation region. The next is the drain to gate feedback resistance. It is similar to the BJT biasing technique in which we had the name collector to base bias. We know drain is analogous to collector, gate is analogous to base. So it is the same technique, but here we have drain to gate feedback resistance RG. Now see one thing that you need to observe is, this is a NMOS. Why NMOS? See, current is coming out of the source. Whenever current leaves the source, this is the case of NMOS. Now the best thing about MOSFET as compared to BJT is that the gate current is 0. There is no gate current, which means the current through this RG is also 0. If the current through this RG is 0, the voltage drop across RG is 0. Okay, there is no voltage drop. That means the drain and the gate terminal are directly connected. Okay, what did I see here? That the drain and gate are connected together. Now if drain and gate are connected together, then what did I tell you directly? I told you that MOSFET is biased in saturation region. That means here we don't need to check the region of operation. We directly know that the region of operation is saturation. In that case, what I will do is, I'll write ID equal to K times VGS minus VT. Now we know that the gate and the drain terminal are connected together. So I can say that the gate voltage is equal to drain voltage. Both are connected. That means gate to source voltage is equal to drain to source voltage VGS equal to VDS. So you can also write it like this, K times VDS minus VT square. Also remember, unless it gives you the coefficient of channel length modulation, you will always ignore the effect of channel length modulation. Otherwise there will be one extra term, 1 plus lambda VDS. Now here we have two variable ID and VDS. I need to form one more equation that I'll form using KVL like this. I'll say VDD minus IDRD minus VDS equal to 0. So VDS is VDD minus IDRD. Now you can substitute this value of VDS in the previous equation. So you can write ID equal to K VDD minus IDRD minus VT whole square. And from here we can compute the value of drain current ID. Once you have the value of drain current, you can calculate the value of VDS, which will also be equal to VGS. Okay. But here we directly know that the operating region is saturation region. So you don't need to validate your hypothesis. This hypothesis is always correct. It will always operate in the saturation region whenever drain and the gate terminal are connected together. So you need to memorize this thing. Whenever gate and drain terminal are connected together, MOSFET is biased in saturation region. The third kind of biasing technique, that is constant current biasing. Now if you remember, when we were studying BJT, I told you the most stable Q point occurs in case of constant current biasing. And if you have been following me, whatever I have been telling in this video, you can observe that the name of all the techniques are exactly same what we study in case of BJT. The names are exactly same. Fixed bias, and then we had collector to base or drain to gate bias. Now constant current bias. In constant current bias, the best thing is that I directly know the drain current is equal to I. It is equal to this current source. But what we need in the Q point? In Q point we need this voltage VDS. Now how to find this VDS? See, the input current here in the gate terminal is 0. If input current is 0, the voltage across RG is 0. That means the gate voltage is 0 volt. Okay. Now we know that the gate voltage is 0. Which means VGS equal to VG minus VS. Suppose I consider this voltage as V. So 0 minus V. It is equal to minus V. Now I will assume saturation region. Okay. Assume saturation region. Then I know the value of drain current is K times VGS minus VT whole square. Now this ID is equal to I. VGS is equal to minus V. So from here we can calculate the value of V. Once we have the value of V, we can calculate the drain voltage. The drain voltage can be simply found out using the KVL. It will be VDD minus ID RD. Now ID is equal to I. So VDD minus I RD. We have the drain voltage, we have the source voltage. So we can calculate VDS. It is VD minus VS. Or you can substitute the value VDD minus IRD minus V. Okay. And whenever we are doing constant current biasing, we will always bias the transistor in saturation region. Why we are so bent on basically biasing in the saturation region? Because like in BJT, BJT was working as an amplifier when it was in active region. Similarly, MOSFET will work as an amplifier when it is in saturation region. Okay, that is the major difference. In BJT, amplifier operation is obtained in active region. In MOSFET, amplifier operation is obtained in saturation region. So that is why whenever we are biasing using constant current, we will make sure that we are biasing in the saturation region so that it can work as an amplifier. The last kind of biasing technique is called as your voltage divider bias. Now remember, when we were studying voltage divider biasing in case of BJT, how did we go about it? First we used to find the Thevenin equivalent. The same thing you can do here is, you can find the Thevenin equivalent, but you can also save the effort. If you don't want to waste much time in this, then think one thing. Why MOS is different than BJT? If I ask you this simple question in terms of circuit analysis, why MOS is different than BJT? The major difference is that the gate current is 0. If you know that there is no current flowing into the gate terminal, then directly these two are in series. Okay, because the current through these resistances will be same, no current is entering the gate. Suppose I current is coming here, I will go here. So no current is entering the gate, both are in series. If both are in series, we can directly write VG. It will be VDD into R2 over R1 plus R2. That will be the gate voltage. Once we have the gate voltage, I will apply KVL like this. What I will do? Gate voltage minus VGS minus IDRS equal to 0. Which means your VGS will be VG minus IDRS. Once we have this relation, what I will do next is, I will assume saturation region. Okay, we will assume saturation region. Once we have assumed saturation region, I will write ID equal to K VGS minus VT whole square. Now this VGS is VG minus IDRS minus VT whole square. From here we can compute the value of ID. Once I know the value of ID, I can calculate this value of VDS by applying KVL. You will apply KVL like this. So I will write VDD minus IDRD minus VDS minus IDRS equal to 0. So that means VDS will become VDD minus ID into RD plus RS. Okay, but here we don't know the operating region, so we have to check whether it is operating in linear or saturation region. For that, what you will check? For saturation region, VDS must be greater than VGS minus VT and VGS must be greater than VT. These two conditions you have to verify. Is it fine? So remember, in the drain to gate biasing technique, by default operating region is saturation. Even in constant current biasing, our region of operation is saturation. So where do we need to check? We need to check in fixed bias and the voltage divider bias. In these two techniques, I am not sure about the operating region, so we have to always check the operating region. Is it fine? Next, let us discuss the current mirror circuit based on MOSFET. As you saw in BJT, how did I design the current mirror circuit? I will show you using BJT also. The current mirror circuit was like this. This was I reference. Now these transistors were NPN. Now see, I have just replaced the NPN transistors by NMOS transistor, but the basic construction of circuit is exactly same as a BJT circuit. So current mirror circuit is exactly same, but we have replaced BJT by MOSFET. Now again, one major difference between BJT and MOSFET. In MOSFET, the gate current or the input current is 0, but in BJT, the input current is not 0. In BJT, we have input current equal to IB. So we called this current as 2IB. Okay. And we checked the value of VBE. If VBE was same, I will say that the transistors are carrying equal current. Now let us go back to the original circuit using MOSFET. Okay. This I just wanted to show you that the circuit is same, just BJT is replaced by MOSFET. Again, you don't have to memorize anything in current mirror circuit. Let me show you how you can do this. This is 0 ampere, 0 ampere. This is also then 0 ampere. That means the drain current of first transistor is equal to Iref. The drain current of second transistor is I0. Now if you see, the gate and the source are connected together, so the gate to source voltage is same. What I can say? VGS1 is equal to VGS2. Okay. And see this transistor. If you see this transistor, the drain is connected to gate. Drain is connected to gate. What did I tell you about this connection? Whenever drain is connected to gate, MOSFET is biased in saturation region. Okay, we know this information, and we know that both values of VGS are same. Now the drain current of first transistor is Iref. So Iref is mu n COX by 2 W by L of first transistor. VGS1 is VGS minus VT square. The drain current of second transistor is I0. So what is the current? Mu n COX by 2 W by L of second, VGS minus VT square. Now if you take the ratio of I0 and I reference, what you will observe? Every term will get cancelled out except the aspect ratio or the W by L ratio. Okay. If transistors are exactly identical, if Q1 and Q2 are exactly identical, then W by L of 2 is equal to W by L of 1, which means I0 will be equal to I reference. Now in BJT we derived the relation as I0 equal to I reference 1 plus 2 by beta. This was the relation. And I told you in BJT base current is 0 if beta tends to infinity. So I0 will come out to be I reference. So you can compare both the relations just like that. In MOSFET we know that the gate current is 0, but in BJT base current is only 0 when beta tends to infinity. So if beta tends to infinity in BJT, we will get the same result as a MOSFET. So in order to obtain the same result in BJT and MOSFET, the beta of BJT must be very large. But the benefit in MOSFET is that whenever you want to realize any current ratio, you can directly do it by scaling the aspect ratio or W by L ratio. So this result needs to be remembered that in current mirror circuit, the ratio of the currents is equal to the ratio of aspect ratios. Now in BJT, when we went forward from current mirror circuit, we saw a bigger form of that, and that was called as your current steering circuit. Now see this. Here this is the source transistor which will carry the current Iref. This is my source transistor. Now it is connected to two transistors. Instead of one, it is connected to two transistors. So how you can write the drain current of second? The drain current of second will be Iref into W by L of second by W by L of 1. Remember in BJT what we were doing? In BJT we were saying if n transistors are connected, we were writing I naught equal to I reference over 1 plus n by beta. Okay. But here the gate current is always 0, so it does not matter how many transistors you are connecting. The relation will always remain same. So it is independent of the number of transistor. Same way you can write ID3. ID3 will be I reference into W by L of 3 divided by W by L of 1. Now if you see, this ID3 is actually equal to ID4, and these two transistors are nothing but PMOS. So this is the current mirror circuit. This circuit which I have encircled, this circuit is also a current mirror circuit, but it is constructed using PMOS. So this ID4 will now work as I reference. So ID3 equal to ID4, it is equal to I reference for PMOS current mirror. In that case you can write this ID5, the reference current is now ID4. So ID4 into W by L of 5 divided by W by L of 4. So that way you can also find out the value of ID5. Is it fine? So remember, only relation that you have to memorize here in current mirror circuit is that the ratio of currents is always equal to the ratio of width to length, or the ratio of aspect ratios. Is it fine? So let me summarize what we have covered in this video. I have told you in biasing, always assume saturation region. Why I am assuming saturation region? Because MOSFET works as amplifier in saturation region. Second, in fixed bias and voltage divider bias, in both these biasing techniques we have to verify the operating region. But when we talk about drain to gate bias and constant current bias, here always the operating region is saturation. Then I have told you about the current mirror circuit. In this you just have to remember the ratio of currents is always equal to the ratio of their aspect ratios. Okay, this is a very simple concept and it is very important from gate point of view. Direct question can be asked based on current mirror. Okay, so in the next video I will show you how to solve problems based on biasing and current mirror circuit. This will be all from this video. Thank you.
For 12 months the pricing is 3250, but if you apply the code Ankit ESE it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2 year subscription becomes 66600. So the choice is your, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these two channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.